95% of the universe is invisible, and we have no idea what it is. I want you to look at your hand right now. Go ahead, actually look at it. You can see it, you can feel it. It's real, it's matter, it's something. Now here's what science has confirmed, and what most people never stop to think about. Everything you have ever seen in your entire life, every person, every mountain, every ocean, every planet, every star, every galaxy visible in the night sky, all of it, every single thing you can perceive with your eyes or any instrument ever built by humans, adds up to just 5% of the universe. The other 95%, we can't see it, we can't touch it, we can't detect it directly. We don't know what it is, and it is everywhere, right now, passing through your body, through this screen, through the entire Earth, completely invisible and completely unstoppable. We gave it a name because we had to call it something. We called it dark matter and dark energy. And the more we study it, the less we understand it. Let me take you back to 1933. A Swiss astronomer named Fritz Zwicky was studying a cluster of galaxies called the Coma Cluster. He was measuring how fast the galaxies inside it were moving, and something was immediately, deeply wrong. The galaxies were moving too fast, way too fast. Here's why that matters. When you spin something on a string, the faster it spins, the more force you need to keep it from flying off. Galaxies work the same way. The faster they move, the more gravity you need to hold them together. Zwicky did the math. He calculated how much gravity the visible matter in the cluster, all the stars, all the gas, everything they could see, could generate. It wasn't enough. Not even close. The galaxies should have flown apart billions of years ago. But they hadn't. Something was holding them together. Something massive. Something completely invisible. He called it Dunkel Materie, dark matter. And for decades, most scientists ignored him. Then, in the 1970s, an astronomer named Vera Rubin did something that changed everything. She studied how stars move within individual galaxies, specifically how fast they orbit around the galactic center. According to everything we knew about gravity, stars at the outer edges of a galaxy should move slower than stars near the center. Just like the outer planets in our solar system move slower than the inner ones. But they didn't. Stars at the edges moved just as fast as stars near the center. The rotation curves were flat when they should have been declining. The math didn't work. Unless there was a massive invisible structure of matter surrounding every galaxy, a hidden shell of something we couldn't see, generating gravity, holding everything in place. Two scientists, 40 years apart, the same impossible conclusion. The universe contains something we cannot see, and it outweighs everything we can see by a factor of 5. Now I know what you're thinking. If we can't see it, how do we know it's actually there? That's the right question, and the answer is one of the most elegant things in all of science. We see its shadow. When light from a distant galaxy travels toward us through space, it sometimes passes close to an enormous mass, a galaxy cluster, for example. And when it does, that mass bends the light around it, like a cosmic lens. Astronomers call this gravitational lensing. Here's the thing, we can calculate exactly how much mass is needed to bend light at a specific angle. And when we look at these lensing events, the bending is always far greater than what the visible matter could produce. Something invisible is doing the bending. We have mapped it. We have measured its effects. We have watched it distort light across billions of light years of space. We know where it clusters. We know how it moves. We just have absolutely no idea what it actually is. It's like knowing a ghost is in the room because you can see the furniture moving, but you can never see the ghost itself. And it gets stranger. In 2006, astronomers observed 2 galaxy clusters that had collided, an event called the Bullet Cluster. When they mapped where the mass was after the collision, the visible matter, the gas, the stars, had slowed down and clumped together from the impact. But the dark matter passed right through, completely unaffected, like the 2 clusters were ghosts to each other. Dark matter doesn't interact with normal matter the way normal matter does. It doesn't slow down. It doesn't collide. It just passes through everything, including you, at this very moment, right now, as you watch this. But dark matter is only 27% of the universe. The remaining 68%. That's something even more mysterious. Something that doesn't just sit there invisibly like dark matter does. Something that is actively pushing the universe apart. We call it dark energy. Here's what we know. In 1998, 2 independent teams of astronomers were studying distant supernovae, exploding stars. To measure how fast the universe was expanding, everyone expected the same answer. The expansion from the Big Bang was slowing down. Gravity was pulling everything back together. That's what the math said. That's what made sense. Instead, they found the opposite. The universe isn't just expanding, it's accelerating. Every galaxy is moving away from every other galaxy, and moving faster every single second. Something is pushing everything apart with increasing force. That discovery won the Nobel Prize in Physics in 2011. And to this day, we have no satisfying explanation for what dark energy actually is. Some physicists think it's a property of space itself, that empty space has energy built into it. And as the universe expands and creates more space, more dark energy is created, accelerating the expansion further. If that's true, the universe will never stop expanding. Every galaxy will eventually accelerate beyond the point where its light can ever reach us. One by one, the night sky will go dark. Galaxies will disappear, not destroyed, just pushed so far away, their light can never cross the distance. In the far future, a civilization, looking up at the night sky, will see nothing but darkness and assume the universe is empty. They will have no way of knowing billions of galaxies once existed. They will be completely alone, not because the universe is empty, but because dark energy moved everything beyond reach. So what are we doing about it? Scientists around the world have built some of the most sophisticated detection equipment in human history, specifically to find dark matter particles directly. Deep underground in an old gold mine in South Dakota sits a detector called Lux Zeppelin, a tank filled with 10 tons of liquid xenon, shielded from cosmic radiation by a mile of rock above it. The idea is that if a dark matter particle collides with a xenon atom, it would produce a tiny flash of light we could detect. So far, nothing. In the Italian mountains, buried under Gran Sasso, another detector called Xenon 1T ran for years with the same goal: nothing. At CERN, the Large Hadron Collider, the most powerful particle accelerator ever built, has been smashing particles together at nearly the speed of light, looking for dark matter signatures in the debris. Nothing. This is what makes dark matter one of the greatest unsolved mysteries in all of science. We know it's there. We've mapped its distribution across the universe. We've built the most sensitive instruments ever constructed to find it, and it refuses to reveal itself. Whatever dark matter is, it interacts with our universe on its own terms, not ours. Let me put this all together for you. Everything humanity has ever discovered, every element on the periodic table, every chemical reaction, every living cell, every star we've named, every galaxy we've photographed, every black hole we've detected, all of physics, all of chemistry, all of biology, everything science has ever described and explained and understood applies to just 5% of what exists. We built the entire cathedral of human knowledge on 5% of reality. The universe didn't give us the full picture. It gave us a glimpse, just enough to make us think we were beginning to understand, and then revealed that 95% of everything is made of something we have never touched, never seen, and cannot explain. We are not explorers standing at the edge of the unknown. We are standing inside it. Dark matter and dark energy aren't just gaps in our knowledge. They are a reminder that the universe operates by rules we haven't discovered yet. That the story of science isn't one of answers accumulating toward completion. It's one of questions growing faster than the answers. Every time we look deeper, the mystery gets larger. And somewhere out there, woven into the invisible fabric of everything, is something that makes up most of reality, waiting. While we look for it with instruments made of the 5% we actually understand,